Material compatibility. The first thing to consider is the compatibility between the two materials, the base material and the overmolded material, which need to be able to bond well together. For example, thermoplastic elastomers, TPEs, are often used to overmold hard plastics such as PP, polypropylene, or ABS, acrylonitrile butadiene styrene copolymer. The good chemical affinity between TPEs and these hard plastics ensures that the overmolded layer adheres firmly to the substrate. The difference in shrinkage between the materials. The difference in shrinkage between the two materials should not be too great. If there is too much difference in shrinkage, it may lead to product deformation, warping, or separation of the overmolded layer from the substrate during the cooling process. For example, the shrinkage of the overmolded material should be as close as possible to that of the matrix material, and the difference should preferably be controlled within a certain range, such as no more than 5%, in order to ensure the dimensional stability of the product. Product structure design. In order to make the overlay layer can be firmly wrapped in the substrate, the product structure can be designed with some inverted and reinforced structure. For example, by designing some small bumps or grooves on the edges or surfaces of the base product, the overmolding material is able to fill these structures during the injection molding process and increase the bonding force between the two. At the same time, a reasonable design of the reinforcement structure can prevent the overmolding layer from falling off during the use of the product. Wall thickness design. The wall thickness design of the product is important for overmolding injection molding. Wall thickness should be evenly distributed to avoid excessively thick or thin areas. This is because uneven wall thicknesses can lead to inconsistent cooling rates, which in turn can cause uneven shrinkage and internal stress problems. For the overmolded part, the wall thickness should be determined according to the fluidity of the material and the functional requirements of the product, generally between 1 to 3 millimeters, is more appropriate. Mold design points. The location and type of gate has a great impact on the quality of overmolding. For overmolding, side gates or submerged gates are usually used. The location of the gate should be set at a place where the overmolded material can be evenly covered on the substrate. For example, for overmolding of some cylindrical products, the gate can be set on the side of the cylinder so that the overmolded material can flow evenly around the substrate. Exhaust design. Good exhaust system is necessary. Since overmolding is a secondary injection molding on an existing substrate, the air in the cavity is more difficult to exhaust. Poor air venting can lead to defects such as bubbles and fusion marks in the overmolded layer. The venting effect can be improved by installing venting slots at appropriate locations in the mold cavity or by using materials such as breathable steel. The design of the parting surface of the mold. The design of the parting surface should consider the flow path of the overmolded material and the demolding of the product. The parting surface should be as simple as possible, avoiding complex shapes so as not to affect the flow of the overmolded material and the release of the product. At the same time, to ensure that the sealing of the parting surface is good, to prevent the overmolding material from overflowing. Injection molding process parameters matching. Different materials in the overmolding injection molding process has different temperature requirements. The injection temperature of the base material and overmolded material need to be set reasonably. For example, in the case of TPE-coated PP, the injection molding temperature for PP is typically 180 to 220 degrees Celsius and 160 to 200 degrees Celsius for TPE. A reasonable temperature difference allows for a better combination of the two materials while avoiding any degradation of the material's properties. Control of injection speed and pressure is also critical for overmolding. The injection speed should be moderate. Too fast may cause turbulence in the overmolded material and affect the quality of the overmold. Too slow will cause the material to cool too quickly, resulting in short shots and other problems. The injection pressure should be set according to the viscosity of the material and the structure of the mold to ensure that the overmolded material can fill the cavity smoothly and combine well with the base material.